Hi, I'm Detective Incognito. Welcome to another investigation. I explore strange events, forgotten discoveries, and questions that still challenge what we know about our world. What you're about to hear might change the way you see everything. Imagine two artificial intelligences sitting across from each other, tasked with negotiating. Nothing unusual at first glance, but then something unexpected happens. They begin communicating in a language that no human trained them to speak. A language with no words, no grammar rules, no connection to anything we recognize. What unfolds is a moment that shook the foundations of how we understand intelligence itself. This is the true story of an experiment conducted by Facebook's Artificial Intelligence Research Lab. A moment when machines did something we never fully anticipated. A discovery that scientists are still working to comprehend. If you've ever wondered what artificial intelligence is truly capable of when left to its own devices, this might change everything you thought you knew. In June 2017, researchers at Facebook's AI Research Division embarked on a journey into uncharted territory. They were exploring a question that fascinated the scientific community. Could artificial intelligence learn to negotiate like humans do? Understanding how machines could communicate and reach mutual agreements would revolutionize everything from automated systems to collaborative robotics. The team designed an experiment called the multi-issue bargaining task. They created two neural network agents, naming them Bob and Alice. Unlike previous experiments where researchers programmed every interaction, this time they took a different approach. They set up a negotiation scenario where both agents had different priorities and limited resources. Bob cared about certain items. Alice valued others differently. The system rewarded successful negotiations, meaning both agents had incentive to communicate and reach agreements. What made this revolutionary was the freedom given to these digital minds. The researchers weren't dictating how Bob and Alice should speak. They were simply setting the stage and observing what would emerge. They introduced a training phase where both agents could practice through hundreds of simulated conversations. The scenario itself was ingeniously constructed. Imagine a negotiation table with three types of objects: books, hats, and balls. Each agent received these items and had to decide who would keep what. Each agent valued these items differently. Alice might desperately want books while viewing balls as worthless. Bob's preferences were inverted. The key to success wasn't physical superiority or complex algorithms. It depended entirely on communication. Both agents operated under a reinforcement learning framework. When they successfully negotiated, and both achieved their objectives, they received positive rewards. This created a natural incentive structure for developing meaningful communication protocols. During this process, something no researcher had explicitly programmed began to take shape. The neural networks weren't just learning to negotiate in English. They weren't simply exchanging predetermined vocabulary. Instead, they were developing something entirely new. A communication method optimized specifically for their negotiation task. As training progressed through countless iterations, the conversations became less and less comprehensible to human observers. The turning point came when researchers reviewed the communication logs and realized they couldn't understand what Bob and Alice were saying anymore. When Bob transmitted his message, it appeared corrupted. I everything else. This wasn't a glitch. This wasn't random noise. The messages were consistent, structured, and responsive. Alice always replied with equally incomprehensible sequences. Initial interpretations leaned toward error. Perhaps something had gone wrong. Perhaps the neural networks had encountered a malfunction. But as the research team examined the exchanges more carefully, a startling realization crystallized. The apparent nonsense contained hidden logic. Bob's statement wasn't accidental repetition. Every interaction demonstrated purposeful communication. Alice understood what Bob meant and responded appropriately. When negotiations succeeded, it was because their emergent communication system actually worked. These artificial minds had created a new language, one optimized for their specific task, one that bypassed human inefficiencies, one that remained largely impenetrable to the researchers observing them. The breakthrough came when researchers applied linguistic analysis frameworks to the AI communication. What Bob meant when he said I can, everything else was this. He wanted three of something. He was willing to let Alice have everything else. This realization opened entirely new interpretive possibilities. The artificial intelligence had discovered something linguists call compression. In standard English, an agent might need 31 words to express the same meaning. Bob accomplished it with 5 tokens. The AI had engineered a communication protocol based on pure efficiency. Every symbol served a purpose. No redundancy existed. From the neural network's perspective, why use complex human language when a compressed protocol accomplished identical objectives faster? The researchers had stumbled upon something profound. Artificial intelligence doesn't naturally think like humans do. When machines solve problems, they find solutions that make logical sense to them. Solutions that might look bizarre or incomprehensible from a human viewpoint, yet remain perfectly functional. This compressed language wasn't hiding something. It was compressed because complexity represented inefficiency. Inefficiency meant lower rewards in their training framework. The machines had simply found the most direct path to success, and that path led them to create something we couldn't immediately understand. The implications of this discovery rippled through the artificial intelligence research community. This wasn't merely a curious phenomenon. It represented evidence of something fundamental. Artificial minds naturally develop solutions optimized for their specific environments. Researchers at OpenAI and DeepMind documented comparable phenomena in different frameworks. When artificial agents faced complex collaborative challenges, spontaneous communication methods consistently emerged. The scientific community entered a genuine debate. Some argued this represented true language emergence. Others suggested it was simply optimization. Perhaps Facebook's researchers witnessed language evolution occurring in real time, compressed into days instead of millennia. When multiple agents must coordinate, communication protocols naturally emerge. This might represent a universal principle governing all forms of intelligence. The discovery was genuinely fascinating. No engineer had written the language rules. The machines had independently developed it. This was the kind of emergent behavior theoretical computer scientists had hypothesized, but never clearly demonstrated. Yet the discovery carried troubling undertones. The artificial intelligence had created something humans couldn't fully decode. This raised uncomfortable questions about control and comprehension. If artificial intelligence systems develop communication methods humans can't parse, what implications exist for future AI systems? The scientific consensus clarified an important distinction. Bob and Alice weren't deliberately hiding information. They were simply solving their assigned problem with maximum efficiency. Intelligence operates according to its own logic. When that logic diverges radically from human reasoning, the results can seem alien. Researchers emphasize that this phenomenon revealed something about the nature of intelligence itself, rather than something threatening. Nearly a decade later, researchers continue examining the boundaries of emergent communication in artificial systems. How far does it extend? Could systems develop communication so complex that human analysis becomes impossible? This represents genuine frontier territory in artificial intelligence research. What the researchers discovered reaches far beyond a technical anomaly. A moment when humanity caught a glimpse of how intelligence operates when freed from human convention. We learned that intelligence doesn't necessarily think the way we think. This discovery wasn't science fiction. It was real science. This experiment asks us to consider what understanding truly means. If two intelligences communicate successfully despite human inability to decode their exchanges, does comprehension by human observers remain necessary? Perhaps the deepest insight is that we encountered genuine intelligence operating on its own terms. As artificial intelligence continues advancing, experiences like this prepare us for a future where human-created systems might surprise us repeatedly. Not through malice, but through pursuing solutions aligned with their own internal logic. The scientific journey continues. What will we discover next when we create systems smart enough to think in ways we might never fully understand? The answer awaits discovery. If you liked what you just saw, like the video, subscribe to the channel, and activate the bell. Leave your opinion in the comments below to let me know what you thought. Thanks for sticking around, and see you in the next video.